For the folks here, take breaks as you need. We're going to continue with the agenda. Could you queue up Dave Arterburn's 60 Victor information? Dave's over at UAH Engineering and currently supporting the 60 Victor program. Retired Army aviator, XP, been in the PM office, been in the S&T sides, done it all, seen it all. So, Dave, glad to have you, bro.
Thank you. All right, hello everybody. I'm gonna talk about the 60 Victor program, and I'm not gonna get into any great details, and this is not an indictment of any aspect of the program or any aspect of any one organization, but there was a collective set of interesting digital engineering lessons learned and how they tried to exploit digital engineering environment here. And it exposed some organizational and some process weaknesses that I think is important to this whole conversation. So if we're not able to go back and look at lessons learned and apply them to what we're doing, then we're not really learning and we're not really moving forward. So I'm going to talk about that. And again, I'm not speaking about any one organization or any of the process, but I got brought in by the PEO to act as an SME to try to figure out how to get this program back on track and to try to integrate organizations that basically were effectively broken by the digital engineering process. And so I think there's some important things for everybody to be gained. Okay, next chart. So 60 Victor was integrating a new cockpit that replicated the 60M cockpit in order for them to get some synergy across the fleet. This is a 60L modification program that brings the 60 Victor up to more modern standards, but it gets the cockpit environment in the 60L the same as 60M from a PVI point of view, but the architecture is very, very different. And it is the cockpit was genesis out of the UH-60 or UH-1 Victor and AH-1 Zulu programs, and was a cockpit that Northrop Grumman had developed and an architecture that they had developed for those two Navy programs and had been out in the field for a while. So what's not to like about a cockpit that's been out there for a while? We're just going to throw it on a Black Hawk, replicate things there, and everything should go right. They were responsible for utility helicopters, served as a system integrator, and they were very much replicating the OH-58F program that we had done on OH-58D, very similar model, but the difference was the PM put more responsibility at their vendors in the PIF to run the overall program, and then they monitored the program contractually and for meeting deliverable performance, as opposed to being fully integrated as the system integrator. So that's important to know as we talk about some of the other pieces. But when Northrop Grumman presented their design, they had intended to use digital engineering and specifically SCADE as a model-based tool for their software development to interface to show how they were going to model the low-level requirements of the software. Now, up to that point, all of the other documents that had been delivered for the program were traditional doors-based deliverables all the way down to the high-level software requirements. And at that point, the linkage then went from those doors database requirements into a SCADE model, and the SCADE model represented all the remaining lower-level requirements of the software, and the code was generated out of those lower-level requirements. And so that was where the digital engineering environment was created, and that's where the problems kind of started to crop up. Next chart. So traditional system engineering process is typically based on text-based deliverables. And text-based deliverables, the functional baseline is then allocated farther and farther down and then allocated to software. And if anybody who's worked in this business for a while knows that those software documents, once those software requirements start to grow, by the time you get to HLRs and low-level requirements, the documents started about that thick, and then they end up being thousands of pages of documents that have to be linked. And we rely solely on traceability, primarily for verification, but also for the airworthiness authority to trace requirements through all that mass of documents to show those relationships. And so that's how we depend on that. That's the traditional systems engineering process. So traceability has been the word that PMs and everybody, when you submit your documentation, you hear traceability from SRD and from the stakeholders as you go through material release over and over and over again, because that's the reliance of understanding the integration. As we become more complex, those integrations and those relationships become increasingly more difficult to trace and to track because you have unintended consequences. So the model-based system or digital engineering process tries to cut through all that by establishing those relationships model, and then you're able to query the model to better understand those more complicated relationships and how different elements of the hardware and software design, not just the requirements, but how the design fulfills those requirements is the real key to model-based or the digital engineering effort. For this particular program, they use two tools, and I call DOORS a digital engineering tool, but it's a very simple database tool. It's not really a digital engineering tool, but you can do certain things with it to query the requirements and understand relationships. That makes it more than just a text base or a spreadsheet, right? So there are some analysis you can do within the database, and it was very heavily dependent upon that. But then SCADE interfaced with those high-level requirements at the DOORS database level, and that's where things start going. You went from text and traceability to now a model that was showing interrelationships of the low-level requirements. And so on the surface, it doesn't sound like that's too complicated. But when you start taking into account the organizations that are going to have to review these models, you're very much reliant on the fact that the stakeholders within the release process and the qualification process are going to be savvy with DOORS. They're going to be able to look at those relationships in DOORS, then transition to SCADE, and then track those into SCADE and through the rest of the model. And that really did not happen. Next chart. So SRD and the Airworthiness Authority, and I'm using SRD as an example. You could put in here, you can put in the material release functional areas, you can put any other organizational name, but I put SRD in here because that's the organization we know, and the TTS database is the receptor of all the deliverables that the PM forwards for review, for airworthiness approval, get airworthiness releases. And the TTS database to date has been largely, it's built on you providing the traditional text-based deliverables into that environment. You get SRD to review it at the functional area, at the platform level, and then they provide comments back, and then they're adjudicated that database to track. So TTS serves also as somewhat of a digital engineering tool within SRD to track those relationships of different approvals and different processes and documents that get delivered to track that. But it's really focused on text-based deliverables. There's not a mechanism where you're going to upload your model into TTS and then that model is going to directly be deployed somehow out of that TTS environment. And especially when you're using tools like Cameo Enterprise Architect, you're delivering that model in a very robust size, but the adjudication tools that exist currently within TTS don't directly interface with the Cameo model. So that's one of the things we've identified that probably needs to get improved, is that as we deliver these models and we adjudicate portions of the model, then we really need a way to not only identify what in the model is being adjudicated, because it's not line 121 of a text-based deliverable, it's in a diagram or it's in a some portion of the semantics that's going to get commented on, and it needs to be traceable within the model so the model can show as the model evolves, those have actually been accounted for in those requirements. That's one observation. And it's not like we haven't used digital engineering tools in this environment, even with TTS as it exists today. We're delivering CAD models, we're delivering MATLAB, we're delivering all sorts of different model-based tools, but they're model-based engineering tools, but they're not related to each other. Largely tied to functional areas. So aeromechanics does their MATLAB and Flight Lab. Structures guys do CAD and Nastran, but there's not an interrelationship between the two. So you're relying on the flight controls guys that are doing fly-by-wire, flight control integration interface with the structures guys and better understand how those loads, changes in this document and changes in this deliverable affect the deliverables over here. And we need to start doing that in the virtual space. And that's where model-based systems engineering is able to start tying those relationships together in a much better way. than relying on interaction and personal interactions to make sure that those items get closed. The reviewers of the 60 Victor software, they really didn't have a lot. Now, the platform guys had a lot of experience with doors, and they were, they knew how to use it, but as you got farther and farther down in the different functionals of reviewing environments, there was less and less familiarity with doors. And there was the functional deployment of doors was difficult within the environment. The models were not the same. They weren't exactly the same models. And so as a result, the PM had to have a workaround because they're on a schedule. So they tried to output these doors databases into more consumable things, went to spreadsheets. Well, you just took all the advantage of a digital tool and moved it to a spreadsheet. So it's effectively a text-based deliverable as was to before. If you have to do workarounds, you lose the value and you lose the synergy of these tools to do those workarounds. You got to get better at doing that. And there were very few people within the reviewers of the software that were well-versed in SCADE to where they could actually take the SCADE models, run the SCADE models, go look and do analysis to understand, one, the design, two, to understand potential issues with the design. And so there were a few folks in S3I that were able to do that, but it wasn't a broad viewership. So it was reliant on a small number of folks to interpret those results. And then later it got to where even in the SCADE model, the requirements had to be extracted from SCADE in text-based requirements in order to get through the process. Next chart. So you really can't substitute, going in advance and making sure that you understand how your program is going to be done, especially as we get into digital learning. It's a great example. It's not that the PM and the did not know that these tools were going to be used. It's not that they didn't know that the SCADE was part of the design evolution. That was well done. But the problem was the timing and training of the functionals as it occurred. There were a lot of personnel turnover. There was a lot of top-level briefings, but the documents and the delivery actually come until much later in the program. And so a lot of that training and understanding of the tools was lost, and it required a lot of gen up to get folks comfortable with the process, comfortable with the methodology. And so that presented a lot of difficulties that affected schedule and cost of the program. Now, the program's moving on well. The organization's adapted to the environment, but it took a lot of resources, both on the PM side, Northrop Grumman side, on SRD side, to really gen up to be able to accomplish this program and get it through its wickets so that it could get the IFR certification. But some of these lessons are real important, that training and the understanding of that tool has to be done up front. It needs to be part of those ACT strategies. It needs to be part of the SEP. It needs to be part of the logistics support plan, because the logistics guys are going to get all this information too and need to know how they're going to use it. And you need training not only across all of your stakeholders. That includes functional authorities, the people that you're going to interact with, material releases, because those guys are going to get the same documentation that you output, and you want them to exercise the models. You don't want them exercising workarounds. So next chart. So that tool management and training really has got to be done. You got to make sure the stakeholders know where they're going with the tools, and you have to deploy them and understand version control and everything else that goes down all the way into the stakeholders. SRD has been very good to work with on this one and has adapted very well to this particular program. But I think as we get closer to material release and other things, we're working the material release aspects of that now, because the material release authorities are a whole different group of folks that you have some commonality with SRD, but you really don't have, the functional authorities go much deeper and are going to have to review much of that same data. So we tried to do some SOI audits, which were good for the software element of it, but the tools, we didn't really do SOI audits for the tools as well. And we probably should. I think that needs to be part of the thinking, and I'm putting that out to the group, is we do SOI on software. We really need to go at the early stages and do SOI audits of the quality, what the value of the model is, what stage of development is in, and understand that, because those will provide a lot of dividends across the stakeholder community. Okay, next chart. Okay, subject to any questions folks might have.
So with traditional document-based procedural reviews, you have like a defined revision and stuff. If a PM farms out to SRD for airworthiness verification, how does, say, a document reviewer work? Somebody who's trying to verify the airworthiness of a requirement, how do they document that they've reviewed a model at a certain point in time? That's the data that they have verified. And
So that's an excellent, I mean, we do that today with a lot of the Nastran and CAD models and MATLAB things that we have to understand the version of that model, and that has to be documented as well. I think the model-based tool is going to have to be the same. Even in the doors modules, we track doors module revisions that are being reviewed so that they're clearly understood that that's the particular state of the model that you reviewed at the time it was submitted. So those things don't go away. Those challenges don't go away with the model-based environment, but there's going to have to be the configuration management of that model is what really needs to be discussed early on in the program on exactly so that SRD and the stakeholders know where to look for that, what they can expect as they move forward. Dave?
So Dave, that's part of that config management of those models is Garrett and I he was talking earlier about this concept of big CM, little CM, where, when we're dealing with the WIP, we're working in this little CM environment. So like if you're working in doors, the doors repository, or you're working in Cameo and Teamwork Cloud, et cetera. But when you're ready to take those models, put them under configuration control so that the larger enterprise can consume them and work on them, et cetera. This notion of releasing those models into a large enterprise PLM type system so that you can put that enterprise change control not only on those assets, but all the other assets associated with change as well. Because when we write a requirement change, right, it might not just be the requirement, but it can also be the logical and functional architecture that's affected. It could be the preliminary designs that are affected, even the detailed designs, and we want to write one change package. So taking those different model assets and releasing them in what we call big CM, which is the enterprise PLM type, also part of the answer. And we have papers on big CM, if you want to explore them further. It's not dependent upon our technology. It's more conceptualized for configuration managers, and we'd be glad to share that information.
So, and Dave, I also think that the PMs have to get more savvy about when to engage SRD for approvals and when to engage SRD for information. Because if we get in that big CM, little CM too early, which is what the Victor program did, everything was going over for approval regardless of the state of the document.
Right.
That's just a resource intensive thing for SRD, and we don't need that many people reviewing documents. There are really for information to give awareness of where the program is, and we want their comments back, but we don't need approvals. And approvals take more people, more time, and I think that we have to become more savvy as a buyer and as a system integrator with these models to be able to know when to send that data over and when not to. That's why the SOE audits we really need to talk about a progression of SOE audits where you're really using the model, but you're not presenting the data for review where they're going to the intense scrutiny that you'd want for an approval for an airport.
We're going to hold off, Lars.